My favorite type of conic section problems to do, and you'll see we'll do this with ellipses and hyperbolas and everything, is when you have an equation and it's not in standard form. Okay, this is what's in what's called general form. We'll go over that a lot more when we get to section 4, looking at general form. But I want to get this in standard form, so I got to do a little bit of work before I pull out all the good stuff from this parabola. Okay, I know, by the way, that it's a parabola because there's only one square term, either x squared or y squared. The rest of them that we do will have both x and y squared. So this is where your completing the square skills are going to come in handy. I'm going to try to get just all the y's, since that's the squared one, on one side. So I'd say y squared plus 2y. Guess I don't need the parentheses yet. Move the 6x and move the 13 over to the other side. If I wanted to complete the square here, to make this a perfect square, I have to take half of 2 and square it and add 1. And if I add 1 to this side, I need to balance it by adding 1 to that side. So the left side now is going to be y plus 1 squared. Okay? It's looking very similar to this. On the right side, I would have had 6x minus 12, but notice I have this 4p out in front, and then it's going to be x minus something, so I want to factor out whatever's in front of the x. So I'll just take out the 6 and make it x minus 2. It's okay if this is a fraction. Fractions are numbers and they need love too. All right? So I look at this and immediately my thought is y's squared, so it's either opening left or right. Because this is positive, it's going to open to the right. The vertex is x coordinate first, then y coordinate. Okay? We said that it opens to the right. And the axis of symmetry now, since this is where I always think it's helpful to draw a quick sketch at 2, -1, and it's going to open to the right. So even though I'm not sure how wide it is, I do that because it lets me know that, hey, my focus is going to be somewhere inside. My axis of symmetry is going to look like that. So what is that? Oh, that's y equals -1. Okay? Then I need to find what the directrix and the focus are. And so to get that, I need to know what p is. And so I can look here and say 4p is equal to 6. So p is equal to 6 over 4, or 3/2. And so I'm moving 3/2 in the x direction to get to the focus. So from here, if I added 3/2 to that, I would get 3.5 or 7/2 -1. If I want to find the directrix, since the axis of symmetry was y equals, this will be x equals, and it's 3/2 and minus 3/2, excuse me, so it would just be x equals 1/2. Okay? Again, if I wanted to find my focal width, it's just going to be the absolute value of this 4p, so it's just equal to 6. So if I wanted to have a more accurate drawing now, I can erase some of those things. Where did we say our directrix was at x equals 1/2? And I know the focal width is 6, so that means if I go up 3 from here and down 3 from here, that'll give me a focal width of 6. Whoops, I got to do it by the focus though, not by the vertex. And then I'm going to have something that's going to open something like that. And again, every single point that's going to be on this curve is equally distant from here and from this line. So if I said, hey, this point right here, the distance from here to here and the distance from here to here have to be the same. If I said, what about this point right here? The distance from here to here and the distance from here to here have to be the same. That's what every single point on this parabola is going to be, equally distant from both the point, the focus, and the line, the directrix. So that's a few different examples, and that's parabolas, everything you wanted to know and love about them.